I'll be talking about how driving models or models that drive autonomous vehicles can benefit from world models. They can benefit from learning more general representations about how the world works. It should speed up the process of learning to plan. They could generalize better in different environments. And I'll be describing an architecture for learning a world model that's based on a model called Dreamer. That's been pretty successful for planning, and I'll show some experimental results. So first of all, this line of work is based on the fact that humans learn a lot of knowledge about the world just by passively observing it. And when we learn end-to-end models for driving, a lot of the representational power of the model goes into perception. So into understanding the scene, understanding the dynamics, and very little actually goes into planning. And we want to capture this common sense knowledge about the world. And one topical example of how to do that at the moment is through language. But in this talk, I'll be describing a world model that focuses on the visual understanding of the world. So how the scene is going to evolve based on the agent's actions. This work could speed up learning to plan. So if we learn really good representations, we could leverage things like maybe doing reinforcement learning inside of the world model, and that should help with learning driving policies. At the moment, learning rewards or this kind of value assigned to a world model state is really tricky for autonomous driving or in the real world. So we use a form of behavior cloning on large amounts of driving data. I guess one thing that's really cool about this kind of like variant of the world model that I'll be describing is that it models 3D geometry. So driving is a robotics task, so it's important that the world model that we use has spatial understanding. And this should also make for a more interpretable world model, which is one of the criticisms of end-to-end learning.